Okay, welcome to this tutorial. Today we want to look at how to solve ordinary differential equations. Kindly subscribe to this channel so that anytime we post an video or tutorial, you'll be able to get it, to be notified. So let's look at how we solve ordinary differential equations. So in this case, we are going to solve zy and dy and dx, which is equal to zx dy plus y squared dy dz. Sorry. So if you have this kind of equation, remember we have to write it in the general form of an ODE, which is this one, which is p dx plus q dy plus r dz equal to 0. Now writing our equation to that form, we get this. We get zy dx minus zx dy minus y squared dz. So if you have this, we need to remember something. Remember, before you even go on with solving this kind of equation, you have to test whether it is integrable. From my previous tutorial, I looked on how we test integrability of ODE. We looked at that, so kindly revisit that tutorial. You'll be able to see how we do that. So what you need to do here is you divide every part by zy squared. So we are dividing this one by zy squared, again this zy squared, and also this zy squared. So if we divide this, we divide that by that, we come up, we'll get this kind of equation. So we are going to get this kind of relationship. So our equation will become that way. So if you look at that one kindly, you'll see that this particular part here can be reduced by inspection, be differentiated to look like that. So this is actually a condensed form of this. That this is basically an application of derivative quotient rule. Remember, in derivative quotient rule, what we do, we take the denominator times the derivative of the numerator, take away the numerator times the derivative of the denominator, and then we do denominator squared. That's the reason we have y dx minus x dy over y squared. So this basically substituting this one with this one with this. So we have this, we have that. So our equation have been reduced to that. So what you need to do now is to get the derivative. That is get integral. So what we are doing here, we are getting integral both sides. And when you get integral both sides, you'll find that this side, this side, the left hand side, will give you x over y, and the right hand side will give you ln of z plus ln of c. So which, by the laws of logarithms, addition means multiplication, so it can be condensed to this can be condensed to this, and this will imply that if you write this one using the laws of indices, you'll find that the e will be raised by x over y, which will be equal to cz, which will be equal to cz. And remember, our interest is to make z subject of the formula. So we divide by c, so if we let that one of that cancels with this, so that z is equal to 1 over c e to power x over y. And if you let our a to be 1 over c, we'll end up having this kind of equation. That's kind of solution. And therefore, basically that is the solution for our ODE given in this case. If you have any question on this, kindly leave a comment down there. If you have a kind of exam question that you need to ask to me to look at, kindly leave a comment down there. And remember also to subscribe to this channel. Thank you for now.